Unit 19, Day 4, exponential growth. All right. So, for each of the following situations, okay, we're going to need to identify the initial amount, A, growth factor, that's B, and R, which is going to be the percent increase. And then we're going to have to write an equation modeling the exponential growth, and then solve for the given time. All right. Now, let's go ahead and just dissect this piece up here. Okay, now, of course we always know y is a thing, that's the output, x is going to be our input today, okay? They're going to give us a time, we're going to plug in for it, alright? And b, all b is it's going to be 1 plus whatever the growth rate is as a decimal, okay? And the rate, you know, if it's, say, 75%, then that's just 0.75, all right? And something that y'all are hopefully going to pick up on is anything that is bigger than 1 is going to result in exponential growth. And tomorrow we're going to deal with what happens if it's less than 1, between 1 and 0 rather, and that's going to result in something called an exponential decay, all right? So, let's see, and then of course A, that's your initial amount. That's however much you invested in the bank to start out with. That's how many people you started out with in a population. It's, you know, whatever it happens to be, it's the initial amount. Also, we have been referring to this as N, or rather, A sub 1, okay? We've been referring to it as that for the last couple of days, if that makes you feel a little more comfortable. All right, now, let's go ahead and look at some of these problems. To start out with, okay, it says the population of a city is 50,000 and is growing at 3% each year. All right, now, A is going to be 50,000. 50,000, and then R is going to be 3%, which is 0.03. B is going to be 1 plus 0.03, which equals 1.03. Okay, from now on, I'm not going to do the addition part. I'm just going to go ahead and just write it out. Okay, now our equation for this is going to be y equals 50,000 on the outside of 1.03 raised to the x power, whatever x happens to be. And x is just going to be the amount of time. All right, now let's look at the next part here. It says, what is the population after 25 years? Well, the formula for that is going to be y equals 50,000 on the outside of 1.03 raised to the 25th power. All right, and if we plug that into our calculator, we'll find out that we get 104,689 people. All right, that's some serious growth. Okay, 25 years, the population of that city has more than doubled. All right, now if you're going to be a city planner, if you're going to be going into politics or something like that, being able to recognize, you know, how cities are growing and stuff is really important. All right, now number 2. It says since 1985, cost of patient care increased 8.6% per year. In 1985, costs were $460 per day. Now, let's see. What are we going to do? Well, A is going to be 460. R is going to be 0.086. B is going to be 1.086. And our equation is going to be y equals 460 on the outside of 1.086 raised to the x power. Alright, now it asks, what is the cost in 1995? Well, 1995 is 10 years after 1985. So, what we're going to say is that y equals 460 on the outside of 1.086 raised to the 10th power. And when we do that, it's 1,049.68. So, in 1995, it would cost you $1,049 to spend the day in a hospital, basically. Next thing, okay, it's asking what is the cost in the present year. Alright, now, let's see. 1985 to present day. Well, let's see. 1985, 2016. Alright, whenever you do that, you get 31. Alright, so y equals 460 on the outside of 1.086 raised to the 31st power. Alright, so a day visit to the hospital in order to just basically stay the night and all that good stuff, $5,935.84. Alright, and that's actually not too far from the truth. It's actually a little more expensive today, but insurance usually covers that. So, if you plan on going into the healthcare system in some way, shape, or form, if you want to be a doctor, you have to understand the billings. You have to understand how the billings have changed in the last few years. You have to understand all that stuff. If you plan on going into the insurance game, this is another piece to it. All right, there is a lot that goes into this stuff, and you have to be able to communicate this effectively. All right, so next thing, we want to talk about the cost of tuition at a college is $12,000 and is increasing at a rate of 6% per year. Let's look at this one. This one, let's see, our A is going to be $12,000. Our rate is 0.06, so our B is going to be 1.06. The equation for this is going to be y equals 12,000 on the outside of 1.06 raised to the x power. Alright, now some of y'all are like, well, I'm not making money off of college, but most of y'all will be spending money on college before too long. Okay, 3 years for the majority of y'all. So, being able to figure out, well, let's see, this college cost this much this year, and it cost this much last year. What kind of a percentage increase was that? And then you can kind of plot it out and figure out, okay, in 3 years, I can expect to pay this much per year. And that's where this is coming from, okay? So, what is the price of the tuition in 4 years? So, let's see. That's going to be y equals 12,000 on the outside of 1.06 raised to the 4th power. And whenever we do that, we wind up with $15,149.70. Alright? That's a pretty standard increase over the course of 4 years, about $5,000 increase. So just be aware that this is how this works. Okay? And then they want to know, well, how much is it going to cost in 10 years? So we go y equals 12,000 on the outside of 1.06 raised to the 10th power. And whenever we do that, we wind up with $21,490.20. Alright, that's not too bad. Alright, number 4. Carter is the project manager for a major company. Every year, his salary has increased by 12.5%. His starting salary was $45,000 per year. Alright, so let's look into this. We got 45,000. And then the rate is 0.125. The B for this one's going to be 1.125. And the equation is going to be y equals 45,000 on the other side of 1.125 raised to the x power. And it asks, what is his salary going to be in 10 years? So we got y equals 45,000 on the outside of 1.125 raised to the 10th power, and that's going to be 146,129. Okay, that's not too bad. That's a pretty good paycheck right there. Alright. Alright, so page 2, the lizard population is 425 and increases 17% each year. So our initial population is 425. Our rate is 0.17. And our B for this one's going to be 1.17. The equation is going to be y equals 425 on the outside of 1.17 raised to the x. And it says, what is the lizard population after 11 years? So we say y equals 425, the outside of 1.17 raised to the 11th power. So whenever we do that, we should wind up with 2,390. Well, the thing is, we don't wind up with exactly that. It's kind of an approximation. If you type that in, you wind up with like a half of a lizard, which, well, that's kind of creepy and animal cruelty, I think. So, yeah, it's just, we're going to round it to the nearest lizard and call it 2,390. So, anyway, moving along. Next piece is actually one of my favorite things about mathematics. It's money. Money is an awesome thing, and it makes it to where people can do math very well. So, in particular, compound interest is very nice and very well organized and neat. It's how banks basically give you more money. If you did things off of just a basic simple interest, you'd actually be getting cheated out of money, which is not good. How most banks do it is they use a quarterly compounding. They basically, every 3 months, they evaluate how much money is in your account, and then they basically give you money for letting them borrow your money. So, yeah, that's how that works. Now, number 6 says that you deposited $500 into an account. So we go 500 for A. The rate on this account is 6.5%. So that means 0.065%. Compounded annually. So this is a bank that's kind of like, we'll just do it once every year. And some banks do it that way. Other banks will do it other ways. So you just got to you'll eventually have to find a bank that does it the way that you like. Now, n is going to be 1, and the amount of time that we're going to leave it in there is 18 years. All right, so the equation for this would be y equals 500 on the outside of 1.065 raised to the 18th power. All right, now, y'all are probably like, well, what about this formula right here? Why didn't you use this? What about dividing by n, multiplying by n, and all that stuff? Well, the thing is, the n for this is just 1. So really what I did was y equals 500 on the outside of 1 plus 0.065 divided by 1 raised to the 1 times 18. And there it is. It's there. Alright, so whenever we do this, over the course of 18 years, that money will compound, and it will give us $1,553.33. Alright? Now, next thing that we need to look at is number 7. Number 7 states that we have invested $1,000 at a rate of 0.03%. It is compounded quarterly. Quarterly just means every 3 months, which means 4. The amount of time is 5 years. Alright, so our equation is going to look a little something like this. It's going to go y equals 1,000 on the outside of 1 plus 0.03 over 4 raised to the 4 times 5. Alright, now you can actually plug this into your calculator exactly as you see it, using the fraction and everything. Alright, and what you should wind up with is $1,161.18. Alright, and then our last one here says that we deposited $200 at a rate of 5% compounded monthly. How much will be in the account after 2 years? The equation for this is very simple, okay? It's going to be y equals 200 on the outside of 1 plus 0.05 over 12 raised to the 12 times 2. And that's going to be y equals 200 on the outside of 1 plus 0.05 over 12 raised to the 24th power. And whenever we do that, we should wind up with $220.99. It's kind of an approximation. Had to round up a little bit. Alright? Alright, last page. So, if you look at this first one, it says to make a table and graph. Now, the easiest thing to do for this is to go ahead and plug this into your calculator. Plug it into your graph in the f of x equals portion, and it will pop out a graph real quick. And then if you press Control T, you will get the table. And all you have to do is just plug things in. You can go -3.5, 1, 2, 4, 8, and 16. Now all I have to do is go ahead and put these onto my graph. I'll go over to -3, go up 0.5. That's right about there. I go -2, up 1, -1, up 2, over 0, up 4, over 1, up 8, and over 2, up 16. So I go ahead and I draw my graph like that. And there we have it. All right. Whoop. All right, now number 10 says that Sal bought a house for $700,000. Over the last 5 years, the values of the homes in his neighborhood have increased in value by 4% a year. An equation to calculate the value of his house after those 5 years. Oh, write an equation to calculate the value of his house after those 5 years. All right, so thing is, if we all think about it, we've been using this A equals AB raised to the X, right? Where B is, in this case, 1 plus whatever it happens to be, whatever our rate is. So our A is the initial value, so that's 700,000 times B, which is going to be 1.04 raised to the X. The only one that looks kind of sort of like that is B. So it's asking us about after 5 years, so we're going to go ahead and replace that X with a 5, and B is the correct answer. Number 11, a quantity increases by 60% every hour. Which of the following is a possible equation for this quantity? Now, A, on the outside of 1 plus 0.6 raised to the X. So that's going to be A on the outside of 1.6 raised to the X. The only thing that looks remotely like that is G. Now I realize that I have an A over here, okay, and they have numbers here. But the thing is, it says any quantity, a quantity. It doesn't say exactly which one. So we just assign that quantity to be A, and we can go ahead and go from there. All right, now George opened a bank account, and the balance in his bank account after T years is given by the equation A equals 1625 times 1.015 raised to the T power. How much did George put in the bank to start? Now, this right here is B, and that's just 1 plus 15%, right? Or rather 1.5%. Okay? T, well, that's going to be time. And then 1625 is the initial value. Now, at time 0, he had $1,625 in the bank. Next thing, number 13, okay? We got the graph of y equals 50 times 1.6 raised to the x shown. Now, it's going to ask us, what is the y-intercept? So we know that it's going to be less than 200, all right? And we know that the y-intercept is not at negative 50, or over 50, up 0. That would be like way over here somewhere. All right? So B is out. So we've got to look at these three values. Now, a lot of y'all are going to jump towards A because it looks like it crosses at, well, less than about 1 and some change maybe, really close to that line. 1.6 is really small. Don't fall into that trap. All right? Thing is, all we have to do in order to solve this problem is look at this number right here. That's the initial value, right? So that means when time is 0, our value is 50. So that means that over 0 up 50 is the correct answer. And there we have it.